So my name is Ivan Zulkov. I come from microelectronic industry, so my past is in semiconductor development. So I did my PhD at UMICORE in Belgium. This is microelectronic research institution. And then I joined UMICORE and I work with a business unit that does everything related to germanium. So we do germanium recycling, we do manufacturing of Ge-VCSEL, which is a chemistry for optical fiber industry, and also we do germanium wafers. So germanium wafers historically are used a lot in space manufacturing, so that they are used in solar cells for satellites. And in this project, so we're also developing germanium wafers for LiDAR technology in that case. So UMICORE's role is to support with germanium wafer development. So we have germanium wafers which are compatible with space solar cells manufacturing. And here in this project, we want to develop a dedicated product which would be serving photonics industry. So the wafer that would work the best for doing epitaxy growth, so depositing materials specific to VCSELs, so these lasers on a substrate, in order to be used in LiDAR application. Well, I think PhotoGeNIC Project is a very good example of a complex project where you have the whole supply chain involved. So we have UMICORE as a wafer manufacturer. We also have companies that will develop epitaxial processes on these wafers. We have companies that will do processing, and we also have an end user involved. So that could provide us with specs on the product. So we would develop something that is really applicable for the industry and could be easily commercialized. So in fact, it's a project where you need expertise in different areas, and we have really best experts in every domain of the manufacturing of the end device. Well, I would probably tell them that if they have an iPhone of the latest generation, they'd have a LiDAR module at the back. So that's an easy example how to explain what the LiDAR is. So that's a device that helps you to map your surroundings, and they could be used in various applications. So smartphone is one example, but also they can be used on self-driving cars, and this is what we want to develop here. So this is mostly for automotive application. This is to help these cars to see around them, also to see in difficult conditions. So if it rains or if it's dark outside, so to help them to see far away, like 200 meters out. And for automotive industry, of course, standards are very high in terms of the operating temperature, in terms of reliability. And this is what we want to achieve with this technology. So to improve it to such an extent that it can be used for automotive vehicles and self-driving cars in the future.